Very good morning to all of you. Myself, Mr. Mabudur Rahman, Assistant Professor in the Department of Food Engineering in KK College of Food Technology, Nasik. Today, I will cover Sterilization and Pasteurization Part 2. So, first of all, see that what is pasteurization. It is nothing but we can say that the process of killing of pathogens in the milk but does not sterilize it. Okay. Milk is heated at 63 degrees Celsius for 30 minutes. Holder method, it is called as what? Holder method, right? At 72 degrees Celsius for 15 to 20 seconds, it is rapid cooling to 13 degrees Celsius. So this process is called as our flash process, right? So you are seeing here the diagram of water bath that will be used for our pasteurization. Another one is hot water bath. Another one is we can say that hot water that is a method of our pasteurization. So here to inactivate non-sporing bacteria for the preparation of vaccine, a special vaccine both at 60 degrees Celsius for 1 hour is used. Right? Serum or body fluids, it containing coagulable proteins, it can be sterilized by heating for 1 hour at 56 degrees Celsius in water bath for several successive days. It is a diagram of our inspirator. So inspirator, it is sterilized by heating at 80 to 85 degrees Celsius for half an hour for 3 successive days. It is used to sterilize media such as Lowenstein, Jensen and Loeffler serum. Temperature at 100 degrees Celsius, boiling kills vegetative forms of bacterial pathogens. Hepatitis virus, it can survive up to 30 minutes of boiling. Endospores, it can survive up to 20 hours or more of boiling. It is our steam sterilizer. This diagram is our what? Steam sterilizer. Steam at atmospheric pressure, steam is generated using a steamer. Consists of tin cabinet, has a conical lid to enable the drainage of condensed steam. Perforated tray to above ensures materials are surrounded by steam, and for routine sterilization exposure of 90 minutes is used. For media containing sugar and gelatin, exposure of 100 degrees Celsius for 20 minutes for 3 successive days is used, and the process is termed as tenderization intermittent sterilization, right? Another one is steam under pressure, that is autoclave. Okay, so autoclave work on the principle of steam under pressure, right? And it is invented by Charles Chamberlain in 1879. So this diagram is our autoclave. Autoclave, it consists of vertical or horizontal cylinder. One end has an opening which is meant for keeping materials to be sterilized, and the lid is provided with pressure gauge to measure the pressure, right? A safety valve is present to permit the escape of steam from the chamber. Articles to be sterilized are placed in the basket provided. Sterilization is carried out under pressure at 121 degrees Celsius for 15 minutes. Another one is the chemical agents. It acts by protein coagulation, disruptions of the cell membrane, removal of sulfur hydryl groups, substrate competitions. Alcohols, ethanol, isopropyl alcohol are frequently used. No action on spores. Concentration recommended 60 to 90% in water. Its uses for the disinfection of clinical thermometer, disinfection of the skin. Next one is the aldehydes. Formaldehyde, glutaldehyde are frequently used. Formaldehyde is bactericidal, sporocidal and has lethal effect on viruses. Glutaraldehyde is effective against tubercle, bacilli, fungi and viruses. Formaldehyde uses to preserve antimicrobial specimens, destroying anthrax spores in hair and wool. 10% formalin plus 0.5% sodium tetraborate is used to sterilize metal instruments. It's used to treat corrugated rubber, anesthetic tubes, face masks, plastic, endotracheal tubes, metal instruments, and polythene tubing. Dyes. There are two types of the dyes. One is aniline dyes and second one is the acridine dyes. So aniline dyes are brilliant green, malachite green and crystal violet, active against gram-positive bacteria and no activity against our tubercle bacilli. Another one is acridine dyes. Acridine dyes in use are orange in color, effective against gram-positive than gram-negative. Important dyes are prophylavine, acrylamine and euphylavine. Halogens. Iodine is an aqueous and alcoholic solution that has been used widely as a skin disinfectant. Actively bacterial with the moderate against spores. Chlorine and its compounds have been used as disinfectants in water supplies and swimming pools. Phenols. It is obtained by distillation of coal tar. Phenols are powerful microbial substances. Phenolic derivatives have been widely used as disinfectant for the various purposes in hospitals. Example is Lysol and Kerosol. Its uses, various combinations are used in the control of phyogenic cocci in surgical and neonatal units in hospitals. Aqueous solutions that are used in treatment of wounds. Next one is the ethylene gases, colorless, highly penetrating gas with sweet ethereal smell, effective against all types of microorganisms including viruses and spores. Especially it used for sterilizing heart lung machine, respirators, statues, such as dental equipment, books and clothing. Also used to sterilize glass, metal and paper surface, plastic oil, some foods and tobacco. Formaldehyde, it's widely employed for the fumigation of operation, theaters and other rooms. Beta propiololactone, it used in fumigation for sterilization 0.2%, has a rapid biocidal activity, very effective against viruses. Surface active agents and metallic salts, it reduces the surface of tension. Surface active agents, caution that are widely used in the form of quaternary ammonium compounds and no action on spores as well as the viruses. Metallic salt, the salts of silver, copper and mercury are used as disinfectant. It acts by coagulating protein, marked bacteriostatic, weak bactericidal and limited of fungicidal activity. Testing of disinfectant, there are the two methods. One is the radial Walker test and second one is the Chick-Martin test. Next one is sterilization by filtration. Filtration helps to remove bacteria from heat, as well as we can say that the following filters we use for filtration. Sterilization by filtration: candle filter, asbestos filter, sintered glass filter and then membrane filters. So you are seeing here the diagram of the candle filter. Candle filters widely used for the purification of waters, unglassed ceramic, as well as it is a filter of sieve filter, asbestos disc. This diagram is our CT filter and asbestos disc filter. Asbestos filter, it is our single use disc, high adsorpting tendency. It is carcinogenic in nature. It is our sanitized sintered glass filter. Sintered glass filter prepared by heat fusing powdered glass particle of graded size. Clean, easily, brittle, expensive. It is our diagram of membrane filter. Membrane filter, it is made up of cellulose, sterilization and sterility testing, water purification and analysis. This will be used. Radiation, it is two type, non-ionizing and ionizing radiation. So in non-ionizing radiation, absorbed as heat and it can be considered a hot air sterilization, for example UV rays. Another one is ionizing radiation. X-rays, gamma rays and cosmic rays are used. It is also called as cold sterilization. Here in sterilized plastic, syringe, cathodes, grease, fabric, metal, foils, etc. Ultrasonic and sonic vibration, that is used in bactericidal microorganism. It vary in their sensitivity, hence no practical value in sterilization and disinfection. Okay, thank you for listening. Once again, thank you.